I don't remember. What was it? I don't know. Okay, I'll give those back to you tomorrow. And listen, are you ready? Here it goes. It is a simple but rather important idea of series. And it goes a little something like this. If you have an infinite series and the terms don't go to zero, it has no chance of converging. It absolutely will diverge ahead of time 100% of the time. Okay? If the terms don't go to zero, terms, not the sum, the terms don't go to zero, then you can't get an infinite sum of infinitely many, infinitely non-zero terms. It must diverge. If the terms do go to zero, it only has a chance. It doesn't have to converge if the terms go to zero. It just has a chance. Might converge. All right? So when you go to see if a series converges or not, and that is a big idea of this class, the first thing you check is, do the terms go to zero so it even has a chance or not? The work needs to just look something like this. If I were to take the limit of the terms, again, not the sum, the terms. Now technically that would be, as n gets infinitely large, that would be infinity over infinity, right? We don't have to do all that Leibniz work. You can just, or L'Hopital work, you can just use magnitude and end behavior. Which goes faster, the exponential or the linear? And so the terms will go to infinity, that's not zero, so diverges. That's what the work should look like, okay? Try that for those 5, and we'll go over them in a minute.
So
A is the term formula itself. So if you wanted to, it helps you to write this. But yes, A sub n is the term generating formula. The terms themselves.
this one was not
You could use it. You could do it like you do in all the others, or you could. surprised me that that's yours. As long as the hardest trick does not kill any brains, we have an essay tomorrow. Ready?
I was really disappointed. No, we literally after.
Okay. For the second one going across, what is the limit of the terms? 2/13. That is not 0. You're adding basically infinitely many close to 2/13-ish. The series must therefore diverge. Okay, what is the limit of the terms? It does not exist. It really fails to converge, but I think you'll agree that the terms do not approach 0. Okay, it oscillates. And so because of that, the series will diverge. All right then. How about this bad boy? This is known as a p-series, by the way, with a p of 1/2. What is the limit? 0. The terms do go to 0. It might converge, not converges. If you have converges, scratch it out or add might converge. In fact, it does not converge, it diverges, but it has a chance at the very least by divergence theorem. By the way, our book calls it the divergence theorem. Most books call it the divergence test. It's a small difference, no big deal. Okay, you could keep plowing ahead using the same methodology for this problem and get the limit is 0 and therefore it converges. That works just fine. As I set up here in the italics notes, if you identify it as geometric, it is also acceptable to say this is geometric with a common ratio of 2/3, which is less than 1, so converges. This actually, sorry, this should say, this conclusion should say might. Did I make a mistake?
When you said converges, Alyssa just started. You said might.
Oh, sorry. Nice. Glad I didn't hear it. If you were to do it that way, it's might. True. If you were to do it the geometric way, that is actually definitely convergent. So either way, it's fine. I'll try harder. Sorry. The limit of the terms here is e. That is not 0, so it diverges. Okay. Keep in mind, as always, please keep in mind there's a difference between terms and the sum of the terms. Do the terms converge here? Yeah, the terms converge to E. Does the infinite sum of all those terms converge? No, it gets infinitely large. Okay, so there's a big difference. Make sure you have that distinction very clear in your mind. Okay, the next, is this the next thing on the notes? Okay. All right. Just like any new operation you learn, when you did exponents in Algebra 1, you learned exponent rules for combining. When you did integrals, you talked about, hey, is this okay? And the answer is yes. But is this okay? And the answer is no. Okay, so each new operation carries with it some rules. Same with series. Okay, so let's talk about a little bit those rules so you know what's allowed and what's not allowed. Say you had a series, the formula for which was the sum of two different things. Maybe it's square root of x plus 2 to the x or something like that. Is it acceptable and is it true that that's the same as the separate series of those two? Well, it says right there, show it. So yeah, you can say it's true. How could you show it? It's helpful to think expanded notation. Okay, what's this equal to? When you put in n equal 1, let's assume it starts with 1. You'd have a1 plus b1. Then you would add to that a2 plus b2. Then a3 plus b3, and so on. Now, that's all addition. And addition is commutative. That is to say then that I could put all the a's together and all the b's together. Okay, so now, isn't that new series of all A's just the series of A? And that being the series of B? And so that's absolutely true. It's a fact. No matter how hard you try, though, you cannot manipulate this to equal that. If you look at, oops, I meant to do expanded notation. If you look at A1, B1 plus A2, B2, and so on, there's not really any arithmetic to do here. I can't, or algebra rather, I can't factor out a greatest common factor. There isn't one. There's really, it's a non-starter. If you were to look at the other side, that would be A1 plus A2 plus A3 and so on forever times B1 plus B2 plus B3 and so on forever. Now, when you were to, if you were to distribute this, wouldn't it be A1 B1 but then plus A1 B2 plus A1 B3 and so on? And that is just not what's going on over here. Over here is strictly just A1 B1 only, A2 B2 only, and that just is not equivalent. Say one of them being 0. You with me? Okay. With that then, would you please try that example? That's how you would use this idea. Sometimes you'll get a sum within a series, and you use that first idea of if it's a sum, I can split that. You should see a lot of geometric work. Please try and practice good geometric work. Identify this geometry. Identify the R. Identify that it's convergent. Then use the formula. All that's good geometric work. Did you get 2?
Yes.
Okay. That's what the work should look like on a geometric problem. You should identify it as geometric. Remember, not every series is geometric. In fact, it's pretty rare. R equals 3/5. Actually, not geometric. Is less than 1. You must give evidence in addition to the test value. It's not okay. I was looking at some of your homeworks. I had some people just saying R is less than 1. You have to give evidence. What is the R? And then say it's less than 1. Okay? Converging, etc., etc., etc. Did I go okay? Okay. These are all pretty intuitive, so I probably could have just. Well, I want it in your notes. All right. So it amounts to rules for dealing with series. Imagine you have these are all infinite series. If this first series converged to a sum, when I say equals A, that means the sum approaches some finite number A. And the second series B converges to some finite number B. then the sum of the comparison, or the combination of the two would be A plus B, and obviously it would converge. Okay? What if A converged to A, but B series diverges? What's finite plus infinite? Infinite divergence. If a series converges and it equaled A, then C plus that series would be C plus A. And C times that series would be CA. This is used pretty commonly when you go to do one of those repeating decimal problems, and the whole thing isn't part of that pattern. You would call this 3.2 plus 0.045 plus 0.00045, and this would be the constant, and this would be the series. Okay, so you just tack that constant on to what you get out of the series. You with me? Okay. If a series diverged, then C plus that diverging series would diverge, and C times that series would diverge, assuming that C wasn't 0. If C was 0, and the series diverged, and you took C times that series, it would equal 0. You might say, what about, isn't that indeterminate? 0 times infinity, isn't that? Yeah, it's not approaching 0. It's 0. C is 0, period. All right, and it's that does 0 up. Okay? 0 wins. Would you consider this problem here? Look at that problem and see what you think about convergence or divergence of that series.
Yikes, we don't even have because E over pi.
He's like in but he's 2.6.
Crap.
But if you separate out and then add to the whole thing, it's 4 over pi. Yep, that's what it says. But she was saying E over it.
Never
E
mind.
over
No,
pi.
E is
No, the second one doesn't. Very unique sentence.
Okay, ready? Now, some rules allow for you to split the two into two separate series, yeah? This guy, what kind of series is it? It is geometric. What's the common ratio? E over pi. It is that less than 1?
It is.
It is 2.7-ish over 3.1-ish. It converges. Okay, and so I'm feeling convergence there. But over here, you might be starting to look at that 4 versus pi. I don't know if it's required. You could just say it fails the divergence term because if you just said the limit of the terms here is infinity, not 0, in that divergence, you would be okay. But in terms of geometric, I was doing a little cleanup to make it a little more friendly. You could split the 4 that way. Then you can definitely see that it's geometric with a common ratio of 4 over pi, and that's not less than 1, so it diverges. Because one term diverges, the sum diverges. Or the whole series, and the original series, 2. Okay, if one part diverges, the totality diverges. Would you play around with changing the index to start with? Sometimes you'll be given one that doesn't start at 1, and you'll want it to start at 1. So would you rewrite the formula so that it would make the same series, but now is starting at 1? You'll have to tweak the inside a little bit. If you're not sure, you could always go to expanded notation. It helps me considerably. Okay, ready? Okay, if you did expanded notation, this is what we are being given here. In order to start it at 1, I would have to take in and add 4. N plus 4 to get 4 to the 5th to start with. And the denominator would have to be n plus 1, right? In essence, you could say it's just 2 more than you had to begin with. Instead of starting at 3, we started at 1, so we had to bump up everything by 2 more, 2 more, 2 more. Okay, last but not least, the exam last year, the true-false went poorly. So let's read these carefully in the interest of time and go through them together. The general term a sub n tends to 0, then this is 0. True or false?
No, it goes to some value, which is crazy.
Yeah, just because the terms go to 0, does that mean the sum of those terms is 0? No, that's ridiculous, okay? Remember, throughout these, distinguish between terms and sum. Terms and sum. If the series, or the sum of the terms converges, then the terms must go to 0. True. The only way it has a chance is if the terms go to 0. So that must have been true. If the sum converges.
Which part's the sum and the terms, or whatever, like on the first one?
Say again.
Like, if it's...
Just because, I would say something like, just because if the terms go to 0, the sum doesn't necessarily. You with me?
Yeah.
Okay. What about 3? The nth partial sum of the series is a sub n. So, what notation do we use for partial sums? S sub n. Partial sum, that's false. Partial sums are S sub n. If the limit of the partial sums is 4, then the series must diverge. False. Okay. Remember, a series converges if the partial sums approach a limit. They're saying right there, the partial sums approach a limit. So the series must converge. If the partial sums approach a limit. That is false. Okay? If the terms tend to 0, the series converges.
True.
True? False? Doesn't have to. It could converge. Doesn't have to converge. False. It has a chance of converging. Doesn't have to converge. And last but not least, you have this telescoping theorem, which I decompose for you. It would look like this: 1 minus a half minus a third minus 4. Is it true that a sub n is 1 minus 1 over n plus 1? False. What is this person who says true confusing you with? S, the partial sums. So, the partial sums are 1 over n plus 1 or 1 minus 1 over n plus 1 and converge. Not the terms. You can see the terms are definitely not 1 minus anything. They're totally wacky. Okay? It's the sums. Over and over, distinguish between terms and sum. Terms and sum. Okay? The terms do not, the terms, yeah, do not approach one another. Okay. How'd this go? The last class said, you weren't this terribly, it's your fault that I'm dumb, blah, blah, blah. They didn't actually say that. It was L62. Haha. Okay. First of all, most starting quiz, did you understand it was logistic?
Yeah.
Okay. It is not exponential, it's logistic, because it's proportional to amount and leftover amount, not just amount. Okay? What is, obviously, P initial is 12, that's pretty obvious. It says, how many more the location will allow? 50 from the initial point. So what's the carrying capacity? 12 plus 50 more, or 62. Carrying capacity was 62. 50 more from the initial point. 62 is what the will allow. So we're looking at 62 over 1 plus. Does this and this allow you to find A? What's A? 50 over 12, yes. 62 minus 12 over 12, or 50 over 12, or if you like, 25/6. Are we cool? E to the negative 62 kt. Just like exponential growth, you cannot find k without a second case. They give you a second case. They say the population is 18 at time 1 year. That allows you to plug 1 in for t and find k. K would be something like 62/18 minus 1 times 6/25, natural log of that, divided by negative 62. Population at time 3 then is something. Oh no, that wasn't the question. When would there be 30 rabbits? So population is 30 at time equal 2.5-ish or something like that? 2.555 years. Okay. All right. The other class asked about 19. Why did they ask about 19? Is that hard?
And can we also
Oh.
areas on the one?
Oh, the areas. Click on it.
Oh yeah.
Okay, so 19, on a trig sub case with a definite integral, where the limits are like 0 or 1, or something nicely trig-ish, then I would strongly suggest you do an indefinite integral. Find the antiderivative, sub back, and then just say this is equal to this expression at the original limits. It is important that you never write the limits on your trig subs, otherwise you're making bad math. Does that get you started, or should I continue?
Yes. About, can you add inverse sine of negative 4/5 and inverse sine of 4/5?
That's your answer?
Well, that's what they got, but then in the back it said like those two added together. So
Inverse sine of negative 4/5.
yeah, but then
And
it
you got
like
difference and they got add?
No. It said add them together, and then you get, because it was 25 over 2 times 3, and then they added them together, and then you got 25 inverse sine of 4 plus 1.
5 inverse sine of 4/5. That's funky. Get this to me by the end of the day.
Well, because if you like this,
Start to finish? Sure. Is anybody staying around?
I got like 25 over 2. I don't know if my math is bad, but well, I can
Let me do this. Here we go. Anybody who's sticking around? Do I have people sticking around, or am I doing this by myself?
No, I am so here, Mr. Richard.
You're so here. Okay. You let x equal 5 sine theta, and therefore dx is 5 cosine theta d theta. So you get now 25 minus 20. I will give it back to you tomorrow. Tomorrow's lesson is relatively short and we'll be good. Okay, so did you get something like 25 out front of cosine squared?
Yeah.
Okay, by identity, that's 25 halves, 1 plus cosine of 2 theta, d theta. We? Okay, 25 halves theta plus 1/2 sine 2 theta. Plus a c. That's
Oh wait, no, it's here.
yeah. If you had the half in, then yes, it would be a 4. You cannot sub for that, so you'll use an identity and call it theta plus 1/2 2 sine theta cosine theta. We?
Yeah.
So at the end of the day, it's 25 halves theta plus. You're welcome. Have a good day. Cosine theta plus c. Now at this point then, we're going to sub back that c to actually blow off. You got 25 halves inverse sine of x over 5. Is that right?
Yeah.
Plus, what sine? X over 5? No.
Yeah.
Oh, just x over 5? And what, x squared, 25 minus x squared over 5? Okay. Okay then. The antiderivative from -4 to 4 then is equivalent to
But then,
this guy . 25 root 25 minus x squared from -4 to 4. We?
Yeah.
I would have paid off to use symmetry and go double 0 to 4. Well, too late now. All right. 25 halves. Are you doing okay, people?
aren't you going to end up with just like inverse sine of 4 fifths?
I'm kind of overwhelmed.
What? We're doing so fine. It's going
No, I'm
great.
doing good.
Okay.
But
Inverse sine of
that quiz really threw me off the rest of the day.
4. Really?
Yeah, I think I got 0 out of 5.
Wow, that's harsh.
Yeah, it's okay. It'll get better.
Yeah, I know, it's just really practice. It's just a wake-up call, or we need more practice. 4 root 25 minus 16, so 9 square rooted, so 3. Are we cool? Are you with me?
Yeah.
Minus, do you mind if I go with, maybe I think it would be better to go double.
You've already put in the, oh wait,
So, do you mind if I go 2, this is an even function, so it's the same on both sides. So I could just say 2 times 0 to 4.
I could,
Okay.
You could do it. When you put in a negative x, it's the same as when you put in a positive x. Which makes, okay, so that makes it 25, and 0 to 4, right? So when I put in 0,
sine is 0.
I get an inverse sine of 0, which is cool, and 0, which is cool. Are we cool? So, 25 arc sine of 4 fifths plus 12. And I distribute. We,
Yeah.
what's really cool is that's equal to 1/2 pi times 4 squared. Because it's equal to the area of this. Oh no, Oh.
Guess what I was just going to ask you about?
Oh. Sorry, I lied to you. The geometry is the circle is from -5 to 5, but the area is only from -20. I take that back.
Oh my god. No,
Okay, hi. Oh, I was supposed to. Oh, I forgot to stop this. Sure, I got it. No problem.